Hello, and today we will be covering SOL A11.8 and SOL A11.9. I hope you enjoy, and I'm going to hand it off to Jonathan for A11.8.
Alright, so first we're going to find out how we find the zero of a function. So let's start with this example problem. If 5 is the zero of the polynomial function h, which statement must be true? Okay, so typically when you're finding the zero of a function, it's going to look something like this. It's going to be x plus or minus a times x plus or minus b, where x is obviously x and a and b are just numbers. So let's apply this to our sample problem here. Starting with a is obviously not the solution because it's referring to the y-intercept, and when finding the zero of a function, that refers to the x. So we know it's not a. And so with b, we know that this isn't either, because this says that 5 is the zero of a function, while this is saying negative 5 is the solution. So we know it's not b either. So that leaves us with c and d, that a factor is x plus 5 or x minus 5. So let's start with x plus 5. So using what we have here, we know that x plus 5, if we plug in x, that makes 5 plus 5, which is equal to 10, which is not a solution to the function because it's not 0. So in that case, let's try d, x minus 5. Plugging in our function, we know that 5 minus 5, and therefore equals 0, which is a solution to the function. So therefore, D is the correct answer.
On to our final topic of this video. Determining line of best fit on a TI-84 plus C Silver Edition calculator. Now let's say you're given a set of data that looks like this. Now, in order to find its line of best fit, we must first find out what type of line it is. So we will go to second y equals, and to find stat plots, we will turn on our stat plot, and we'll go to graph, and we see we have this set up for our data. Now we need to find out what type of line will go with this data. So, we will first try and see if it is linear. So we will do 0.1x graph. Now this line doesn't look like our data. It doesn't match our data, so it isn't linear. So, we will now just try to see if it is quadratic. So we'll go with x squared graph. That also does not look like our data set. So, we will see if it is logarithmic. With log of x plus 40 graph. And this also does not look like our data set. So this time we're going to go with an exponential with 1.1 to the x graph. Now this line looks like our data set. It's close. So now we're going to go back to stat. And we're going to go to calc. And since we know that it is an exponential line, we're going to go down to xbreg to find its line of best fit. Go down to calculate. Now we have A equals 1 and B equals 1.023373892. Now for convenience, we are going to round B to the nearest 10,000. So we'll have 1.0234. So we're going to go ahead and put that into the calculator. One 1.0234 to the x, and we will graph. And this line looks like it fits our data. So there we go. We have found the line of best fit for this data set. And now that when we calculated, we got our formula. So now that you have a formula and how to put it together, if you were to want to go out and find what y equals, if you're given an x, you can go ahead and do so. But today we are just finding the line of best fit. But finding that line also gives us the ability to find y if you have an input for x. But we have our line here, and thank you for watching.